Okay, question 40, another very challenging question. Which compounds produce 3 different organic products when hydrolyzed? Okay, first of all, what is hydrolysis? Okay, and what are we hydrolyzing? Hydrolysis is the reaction with water, okay, and basically the water will split this compound into its products, okay? Now, hydrolysis, just for future reference, this is normally done under acidic conditions, okay? So we call this acid hydrolysis. It doesn't mention that in the question, but that could well be something that confuses you in the future, because if you're reacting with a dilute acid, for example, you might think the reaction's with an acid, but it's not with an acid, it's with water, and the acid is acting as a catalyst. So the acid would act as a catalyst. Okay, so hydrolysis is basically the splitting up using water, and then we need to work out what type of organic compound we're dealing with here. Okay, I'm going to highlight the functional group in each of these skeletal formulas. So there's our functional groups. There, and hopefully you would have recognized that what we've got here is a carbon double bonded to an oxygen, single bonded to an oxygen, and then I'll do these in slightly different colors. And then we've got our R group there and our R group there, okay? So this is an ester. So very, very important. So what we're looking at in this question now is the hydrolysis of esters, okay? Now just to kind of, again, add a bit of background information, one of the ways we make esters is by reacting a carboxylic acid and an alcohol. And in that reaction, water is produced. In other words, it's a condensation reaction. You get a molecule of water produced when those bonds are broken and made. Now, essentially what we're doing here is the opposite, okay? We're actually using water, okay, and adding the water into the reactants, to make the products, okay? So in the case of hydrolyzing an ester, we are going to produce a carboxylic acid and an alcohol. I'll repeat that last bit. When we hydrolyze an ester, we make a carboxylic acid and an alcohol. And I've just written that out there. So hydrolyzing an ester with an acidic catalyst, we are going to produce a carboxylic acid and an alcohol. Now, in order to understand what products are being formed here, I'm going to draw out optional 1 here in a bit more detail, okay? Right, so here's option 1 in its skeletal formula, and here I've drawn it out in greater detail, and I think this is going to help us understand what is going on. Okay. So what's going to happen when you hydrolyze this? You're going to break this bond here, okay? And you're going to break this bond here. So it's the carbon single bonded to oxygen that's going to break. Remember, in each of these cases, we're adding water and producing a carboxylic acid and an alcohol. So hopefully, because you've already got your carbon double bonded to oxygen here, we can see that this part of the compound is going to be producing the carboxylic acid, okay? So I'll add on the OH there, okay? So logically then, it must be this part that is producing the alcohol. And if I do exactly the same thing over here, I am just going to change this line to blue here to avoid confusion. Okay, that was our bond broken. So this part here, again, carbon double bonded to oxygen, that's going to be the part that forms the carboxylic acid. And then this is the part that's going to be forming the alcohol. And hopefully now you can see that what we've got there is the addition of H2O. That's our water molecule that has been added, okay? So now we can actually draw out what compounds are being produced, okay? So I'll do that now. Okay, so I've attempted to kind of expand what's going on here, and I've drawn out this compound produced here. So I'll draw a circle around it. Let's use a different color. So here, if I cut off this part, we are producing this, okay? And we should know that's a 2-carbon carboxylic acid, so that's ethanoic acid. And then our second compound here, which is essentially this part here, okay? I'm not quite sure how to name this without thinking, so I don't really need to though, do I? Okay, so we've got a functional group of a carboxylic acid on one side, and we've got a hydroxy group on the other side. And then our third one here, okay, we're producing an alcohol, so this is methanol here. That is this part of the compound, okay? So the water has come up and split this compound into three, and there are actually three different products that have been made, okay? So we don't actually need to go any further into this. We've worked out here that number one as an option is definitely correct, okay? Which compounds produce three different organic products when hydrolyzed? So number one would be correct because all three are different. Now let's have a look at number two. Okay, so we need to get in the habit as well of doing these things quicker. So now that I've explained this one in great detail, this second one here, hopefully we can just work it out. What am I going to do? Well, I'm going to just put a line in there where the bond is splitting, okay? We know that this part here is going to form the carboxylic acid group. This part here is going to form the alcohol group, okay? And the other place where this molecule will be split up is here, okay? Now, hopefully it should be quite easy to notice that the alcohol that is being formed here is going to be the same as the alcohol being formed here. So you're not going to get three different organic compounds here. You're going to get two that are the same and one that is different, okay? And that's going to actually be a dicarboxylic acid there in the middle. So two is not an option, that's wrong. Let's look at this third one. This does look a little bit more complicated. Again, let's just kind of draw a line in where these bonds are going to be broken. So we're going to have that broken there. We're going to have that broken there, okay? So let's have a look. All right, so the reasoning behind why this can't be an option here is slightly different. We're actually only producing two compounds here, okay, because we've got this one that's been produced here, okay, and then we've got a longer one here, remembering that this is the only place where the bond is broken. So we're actually making a compound here that is kind of a little bit of a weird shape. It's like that, okay? You could think of it as some sort of claw there, okay? So you're only producing two compounds. So this can't be correct because it's not even producing three compounds, okay? It's producing two. The two are different, but it's only producing two. I hope that explanation has helped. Bye.